So this is the second day for properties of real numbers. This day kind of solely focuses on one specific property that encompasses quite a few things. So it's the equality property of operations. And this property just states that any operation performed on one side of an equation must be performed on the other side. So what this kind of helps us do is actually solve equations. And it just says that if I do something to one side of my equation, I must do it to the other side. It keeps my equation true. So these 4 bullets below, they kind of talk specifically about specific operations. So the first one talks about adding. So adding the same number to both sides of an equation will result in the equation still being true according to and we just used whatever we're doing. So if we are adding basically here, which is what they're saying, we're adding, then it's just the addition property of equality. So the next one would be very similar. This one says subtracting the same number on both sides of an equation. So now we're just subtracting. We'll keep that equation or result in the equation still being true according to the subtraction property of equality. So this just says that if I subtract on both sides of an equal sign, then my equation will still hold true. The third rule says that, and you can kind of see the pattern here, that by multiplying the same number on both sides of an equation, what that does is it allows the equation to still remain true according to, and again, if we are multiplying, right, then it's the multiplication property of equality. And then the last one says that if we divide by the same number on both sides of an equation, it will keep the equation true. So again, we're dividing here, and that would be called the division property of equality. So whatever operation you're doing on both sides of the equation, that kind of is how you get the name of the equality property we're speaking of. So there are 4 specific equality properties, but overall, these properties are called the equality properties of operations. So example 1, what is different between lines 1 and 2? So when we look at these 2 lines here, I'm trying to figure out what's different. So when I look at line 1, I see 4 parentheses 3x squared plus 2 minus 9 equals 8x squared plus 7. And then line 2 says 4 parentheses 3x squared plus 2 equals 8x squared plus 16. So when I'm comparing, I can kind of just look at this side here first. And when I compare those 2 sides, I notice that the first line has a minus 9 in it and the second one doesn't. Then when I look at the other side, I notice that the 7 and the 16 are different. So now I have to think to myself, how would I get rid of a minus 9, right? How would I eliminate it and make it cancel out? Well, remember our properties from yesterday, the inverse property says that if I take a positive 9 and add it, it will allow me to cancel out, which is why it's no longer there. But remember, my equality properties from today say that what I do to one side, I have to now do to the other side. So 7 plus 9 is how we got that new 16. So basically what we did here was we added 9. So as soon as I say that I added, if I go down now to answer the question below, this was actually a Regents level question. I broke it up for you guys and kind of made you look at the actual crux of the problem. Now we could answer it. So it says, when solving this equation, Emily wrote her first step down. So this is your line 1 here. And then this is line 2. I broke this up for you. Which property justifies her first step? Well, we said that we added 9, right? That's what we did. So when we look at our properties here, we have number 1, the addition property of equality. That's exactly what we used in order to solve or keep this equation equal. So now we're going to use that same method to answer the next question. Again, what is different between lines 1 and 2? So when I look at line 1, I'm not even looking at the question below. I just want to know what did I do to make line 1 look like line 2? So when I look here on the left side of my equal sign, a 5 changes to a 12. And I had a -7, and now it's gone in this line 2. So how would I get rid of a -7? Well, again, I would use my inverse properties, and I would have to add 7. So again, if I add 7 to both sides, the 7s here will cancel, which is why I have nothing in this space next to my 8p. And now I got a 12 here. 5 plus 7 gave me that 12. So again, what did we do here? We added 7 to keep the equation equal. So when we look below, it says when solving p squared plus 5 equals 8p minus 7, Kate wrote p squared plus 12 equals 8p, which is exactly what our lines 1 and 2 said. This is line 1, this is line 2. What property did she use? Well, adding 7 to both sides of an equation is my, again, equality property of addition. We added to keep our equation equal. So now what we're going to do is we're going to use the same method as examples 1 and 2, meaning we're going to look to find what's different, and then we're going to answer the question. So it says a part of Jennifer's work to solve the equation 2 parentheses 6x squared minus 3 equals 11x squared minus x is shown below. So again, this would be like you're given your line 1. That's what they gave us in the original problem. And then when you go to step 2, I'm looking to see what's different. So in line 1, or the given, I had parentheses, right? And in step 1, I no longer have them. What I did to get rid of these parentheses is a property we learned yesterday. So we took the 2 and we actually distributed it, because 2 times 6 gave us 12 and 2 times -3 gave us the -6. So this isn't one of our equality properties. Rather, it's the distributive property of multiplication over subtraction. Again, comparing the given to step 1 is super helpful because you can visually see what's changing. And it's nice to ask yourself before you actually answer the question. Without reading this part here, just look at what's happening and kind of discuss it with yourself. So we're going to do the same thing. We're going to analyze what's different from one step to the next. So when solving the equation 12x squared minus 7x equals 6 minus 2, parentheses, x squared minus 1, Evan wrote 12x squared minus 7x equals 6 minus 2x squared plus 2. So if I just kind of focus on the left side, I have 12x squared minus 7x. And if I look below, I still have 12x squared minus 7x. So that didn't change. Now if I go in on the other side, I have 6 minus 2 parentheses x squared minus 1. And then what happens is my parentheses are no longer there. I have now 2x squared plus 2. So I had this 2x squared minus 1 that changed to 2x squared plus 2. And I'm sorry, this was a minus. So what did I do to get this? I actually took this here and distributed it. And that's how I would get this second negative 2x squared and then plus 2. So again, what did I do? What is this called when we multiply into the parentheses? Well, again, that's my distributive property of multiplication over subtraction. So again, not one of our equality properties, but it's still one of the properties we learned this week. So let's do the same thing here. Analyze the problem to step 1. Brittany is solving a quadratic equation. We haven't even learned what a quadratic equation is, but we don't need to know that because the question is just asking you, how did I get from step 1, the original problem, to step 2? So in this case, if you analyze the two sides, there's more than one thing that changes. So if we look at just the left side here and we compare it to the step 1, right? Something changed or something happened. And what happened is, or what changed is, my -8 and my -10x switched positions. They changed their order, right? They switched. So the property that says we can change order, right? Remember that from the other day, CO, that's my commutative property of addition. So that's my commutative property we just used. Now when I compare the other side of this equation, we have 3 parentheses 2x plus 3, and it changes to 6x plus 9. So how did I get rid of those parentheses again? So to get rid of parentheses, we have to take the term on the outside and we have to distribute it to the inside. So I kind of just gave it to you. If you're multiplying into the parentheses, 3 times 2 is 6 and 3 times 3 is 9. Again, that's my distributive property. So not only did I use the commutative, but I also used the distributive. So the question actually says, which 2 properties did Brittany use? So she did 2 things here. She did the commutative and the distributive, which is choice 4. Okay, example 6. John was given the equation 4 parentheses 2a plus 3 equals -3 parentheses a minus 1 plus 31 minus 11a. Whew, kind of a long equation there. Some of the steps and their reasons have been given for you. State a property of numbers for each missing reason. So same thing, guys. We are just looking to see what's changing. So here, from step 1 to I'm going to call them step 1, and then this was step 2, what's different? So the first thing I noticed that's different is that I'm missing parentheses from here to here. And how would I get rid of parentheses? Well, I would distribute. We just did this property. 4 times 2 is 8, and 4 times 3 is 12. And now again, if I keep analyzing this, -3 parentheses a minus 1 changes to become -3a plus 3. So again, what did I do? I had to distribute. So to get from line 1 to line 2, we had to distribute. So we use the distributive property. Then they kind of already answered the next one for you. They said, well, what changed here? And they said they combined like terms. So on the left side of the equal sign, nothing changed. But on the right side, what they did was they added 3 and 31 to get 34. And then what they did, was they took -11a and -3a and added them together to get 14a. So they combined like terms. Then to get from here to here, things change, right? From line 3 to line 4, now we have our 8a became a 22a. My 12 stayed where it was, but I'm missing now this -14a. So how do I get rid of this -14? So we talked about this. This was one of the properties we learned today. So to get rid of a -14a or a -14a, we do the addition, but what we do to one side, we have to do to the other side. So here, these cancel out. That's why it's gone underneath. And 8 plus 14 is 22. So what did we use here? We used the addition property of equality. This was one of the properties we talked about today. So this is actually all the questions that we just kind of have been working on. They are Regents questions, and they are a little bit more difficult. They're definitely wordy, but we're looking at them this year for the reason of learning how to kind of conquer these types of questions. Okay, so that is the end of the lesson. If there were any questions that you still don't understand, please always email me.